What if I told you that the answer to Britain's heating crisis has been sitting under your feet this entire time? Not in some experimental lab, not in a multi-billion-pound government program, not in a technology that won't exist for another 20 years, but in something so simple, so cheap, and so shockingly effective that energy companies absolutely do not want you to know about it. We're talking about sand. Ordinary, boring, everyday sand. And right now, a growing number of households across the UK are using it to heat their homes through the entire winter. Without gas, without sky-high electricity bills, and without relying on an energy grid that has already failed millions of families. If you've ever opened a heating bill and felt your stomach drop, stay right here. Because what you're about to discover is going to completely change how you think about energy. And before we go any further, if this is the kind of content that actually matters to you, the kind of information that saves real money and gives real energy independence, hit that subscribe button right now and turn on notifications. Because we cover the breakthroughs the mainstream media ignores, and you do not want to miss what's coming next. So let's start with the problem. Because you already feel it. Every October, something quiet and terrible happens in households across the United Kingdom. People start making decisions. Do I turn the heating on tonight, or do I put on another jumper? Do I heat the whole house, or just the room I'm sitting in? Do I eat a proper meal or pay the gas bill? These are not hypothetical choices. These are choices that millions of British families made last winter, and the winter before that, and the winter before that. The UK has some of the leakiest, least efficient housing stock in Europe. The average British home loses heat at an alarming rate, and the systems we use to replace that heat, gas boilers, electric radiators, heat pumps that half the country still can't afford, are bleeding families dry. Energy costs in the UK have increased by over 60% in the space of just a few years. And the promises to fix it, to cap bills, to make energy affordable again, they come and they go, and every autumn the heating bill arrives anyway. But here is where the story changes. Because somewhere in this crisis, a group of engineers, homesteaders, off-grid builders, and energy researchers looked at the problem from a completely different angle. They didn't ask, how do we make gas cheaper? They asked something far more dangerous to the energy industry. What if we stored the sun's energy, or wind energy, or cheap overnight electricity so efficiently that we barely needed the grid at all? And the material they landed on? Sand, cheap, abundant, completely non-toxic, impossible to run out of, and hiding a thermal superpower that most people have no idea exists. Here's the science, and it's simpler than you think. Sand, when heated, stores thermal energy with remarkable efficiency. Unlike water, which boils at 100 degrees Celsius under normal pressure and then becomes useless as a storage medium, sand can be heated to temperatures of 500, 600, even 700 degrees Celsius and just sit there, holding that energy. Not for hours, not for days, for weeks, possibly months. The physics behind this has been understood for decades, but the technology to actually build practical, affordable sand battery systems for homes, that has quietly arrived. And the numbers are staggering. The first commercial sand battery in the world was installed in Finland in 2022 by a company called Polar Night Energy. That system is a 7-meter tall structure holding 100 tons of locally sourced sand. It connects to a district heating network, warming homes and commercial buildings, including a municipal swimming pool, through the brutal Finnish winter. The system reaches temperatures of around 600 degrees Celsius and has achieved operational efficiency between 60 and 70%. Larger systems perform even better, with the 2-megawatt version hitting 85% round-trip efficiency. In June 2025, the world's largest sand battery was commissioned, a landmark moment that barely made headlines in the UK, but it should have been front-page news, because it proved something enormous. This technology works. It works at scale. And the cost per kilowatt-hour of thermal energy stored in sand is a fraction of what lithium-ion battery storage costs. Now here's where it gets very interesting for ordinary British homeowners. Because while the industrial-scale systems are genuinely impressive, the concept has inspired something even more exciting, the DIY sand battery. And this is the version that costs around $300 to build. Think about that for a second. £300, that's less than a month's gas bill for many UK households. And yet, with the right build, the right insulation, and the right setup connected to solar panels or cheap overnight electricity, a properly constructed home sand battery can store enough heat to dramatically reduce or even eliminate your dependence on gas for space heating. How does it work at the home level? The basic principle is identical to the industrial version. You take an insulated vessel, a steel container, a repurposed water tank, a purpose-built box, and you fill it with dry sand. You bury electric heating elements inside the sand. When your solar panels are generating excess electricity during the day, or when grid electricity is cheapest, typically in the early hours of the morning, those elements fire up and heat the sand to very high temperatures. The sand absorbs that heat and holds it. Then, when you need warmth in your home, the system releases it, either by blowing air over the heated sand and circulating it through your home, or by using the stored heat to warm a water loop that feeds your radiators or underfloor heating. The result is that you are effectively charging your heating system like a battery, using cheap energy when it's available, and deploying it when you actually need warmth, independent of what gas prices are doing, independent of what the energy companies decide to charge you next quarter. The breakdown of a basic DIY build is where the $300 figure comes from, and it's remarkably straightforward. A decent insulated hot water tank runs about $300, or you can build your own insulated vessel for less. Pipework adds around $100. A circulation pump, or you can use an existing pump from a hot water tank setup, is another $100. And the sand itself, around $50 for a quantity sufficient to begin storing meaningful amounts of heat. Total material cost, somewhere between $500 and $700 for a fully functional system at the higher end, or as low as $300 if you're resourceful with sourcing components. For context, a heat pump installation in the UK typically costs between $7,000 and $15,000. An air source heat pump, currently being pushed by the government as the future of home heating, requires massive upfront investment and often requires upgrading your insulation, your radiators, and sometimes your entire heating circuit. A sand battery system, insulated vessel, heating elements, sand, pump. That's it. But wait, because here is the part that the energy industry really doesn't want you to think about. If you pair a home sand battery with a modest solar panel array, you've created something remarkable, a closed loop. During summer, your panels generate far more electricity than you can use. In a normal setup, that energy goes back to the grid, and the energy companies pay you a pittance for it under the Smart Export Guarantee. But what if instead of exporting that electricity for pennies, you drove it straight into your sand battery, charging it up with solar heat through the long summer days? The thermal energy stored in a well-insulated sand battery can be retained for months with remarkably little loss. A properly insulated system loses roughly 50% of its stored heat over a period of about 2 months. That means energy stored in August is still available, still releasing warmth, in October. Energy stored in September can carry you well into November, and if you're topping up with cheap overnight electricity throughout the winter, you're looking at a heating system that costs a fraction of what a gas boiler costs to run. Now let's be honest about the challenges, because this is not a magic solution for every home in every situation, and anyone telling you otherwise is oversimplifying. The sand battery excels at one thing, storing and releasing heat. It does not generate electricity. It does not replace a gas boiler for homes without any solar generation or without access to cheap off-peak electricity. The insulation has to be genuinely good. Poor insulation means heat loss that defeats the purpose. And for homes that need very high-temperature hot water for traditional radiator systems, engineering the heat exchange correctly requires some technical knowledge. These are real constraints, but they are engineering constraints, solvable problems, not fundamental barriers. And for the growing number of UK homes with solar panels, with off-peak electricity tariffs, with the inclination to invest a few £100 and a weekend of work, the sand battery represents something almost radical, energy independence from the ground up. And this is where we need to zoom out and see the bigger picture. Because the United Kingdom is facing an energy transition that is, frankly, going badly. The government is committed to phasing out gas boilers. The industry wants to sell heat pumps, but heat pump adoption is slow, expensive, and complicated for millions of older British homes with poor insulation and older heating infrastructure. Meanwhile, the renewable energy being generated by the UK's wind and solar capacity, which is genuinely impressive and growing, often has nowhere to go. Grid storage is a bottleneck. On windy nights, turbines are sometimes paid to switch off because the grid can't absorb the electricity. That is energy going to waste. Energy that could be captured in sand batteries across hundreds of thousands of homes stored as heat and deployed through British winters. The sand battery is not just a clever DIY trick. It is a distributed, democratized version of exactly what Finland proved works at industrial scale. And the UK, with its miserable winters and its catastrophic housing insulation problem, is arguably the country in the world that needs this most. The Finnish sand battery that launched this revolution stores 8 megawatt-hours of energy, enough heat energy to warm roughly 2 average UK homes through an entire winter from a single charge. That is the power we are talking about. Not theoretical, not experimental, measured, verified, and operational. And the principles are fully scalable downward to a domestic system sitting in your utility room or garden shed. Here's something that will genuinely surprise you. The researchers and engineers who analyzed the home-scale version calculated that a typical UK home requires approximately 400-500 kilowatt-hours of heating over a winter. A properly sized, well-insulated sand battery system can realistically store 2 to 4 megawatt-hours of thermal energy at home scale, which means that with smart charging and solar input, you can cover a very significant portion of your winter heating needs from energy you've already paid for or generated for free. The running cost drops to essentially the cost of the excess solar electricity, which in many cases is zero because that energy would otherwise be exported at low rates or wasted entirely. Now here's the question you should be asking yourself. If this technology works, if it's this cheap, and if it solves such a massive problem, why isn't every house in Britain building one? And the answer to that question is both infuriating and entirely predictable. Because there is no profit in it. The energy companies that supply your gas make money every time your boiler fires. The companies manufacturing expensive heat pumps make money on every 10,000 hours installation. The grid operators make money on every unit of electricity that flows through their infrastructure. A sand battery charged by your own solar panels, sitting in your back garden, heating your home for months on stored sunshine, that profits nobody but you. And that is precisely why you've never seen it advertised, never seen it subsidized, never seen it on a government list of approved home improvement grants. The system has no financial incentive to tell you about it, but now you know, and knowledge is the beginning of energy freedom. The technology is real, the physics are proven, the first commercial systems are operational. The world's largest sand battery went live in 2025. The DIY builds are working, the costs are within reach of ordinary households, and the potential, for British families specifically, who have been squeezed by energy prices year after year, is enormous. This is not a fringe idea from the internet. This is a technology that has already transformed heating for communities in Finland, that researchers at serious institutions are studying and refining, and that is quietly beginning to spread to homes that are simply done, waiting for the government to fix a problem. It has clearly decided to leave in the hands of the energy industry. Winter is coming. It always does. The question is whether you'll face it the same way you faced the last one, watching the meter run, rationing heat, hoping the bill won't be worse than last year, or whether you'll be one of the people who figured out a different way. The information is out there, the materials are available, the science is real, and the window to act before next winter is not as wide as you think. So share this video, show it to someone who is struggling with their heating bills, because the solution is not going to come from Westminster. It's going to come from garages and back gardens and people who decided they'd had enough. Don't forget to subscribe. Every single video we make is about exactly this kind of knowledge that nobody else is putting in front of you. And we have something coming next that will make today's video look like a warm-up. You will not want to miss it.